Hello everyone and welcome to Rationalizing Denominators that have binomials in the denominator. So again, when we rationalize our denominators, we are trying to clear out the radical out of our denominators. Now, to rationalize a denominator that has a binomial in your denominator, we want to multiply the numerator and the denominator by the conjugate of the denominator. Factor and simplify if possible. So what are conjugates? Conjugates are the sum and difference of binomials. So if I have the sum of a binomial in my denominator, a plus b, then I will multiply the numerator and denominator by a minus b. If I have a minus b in my denominator, then I will multiply the numerator and denominator by a plus b. Now remember, we have a special rule for multiplying sum and differences of binomials. If I have a plus b times a minus b, the shortcut to that would be to use a squared minus b squared. For example, if I had, let's say, the square root of x minus 2, the conjugate of that is the square root of x plus 2. Now, I could use FOIL or my full distributed property to multiply it out, but we have a special rule for that. The first term squared minus the second term squared is the shortcut to that. So the square root squared, remember that exponent and that root would just cancel each other out, would just give me x. 2 squared is 4. So my answer will be x minus 4 when I multiply that out. So remember to use your shortcuts. You may also end up using the shortcut of a plus b squared, which will be the first term squared, plus 2 times your terms, plus the last term squared. Or a minus b squared, which is similar to the a plus b squared, first term squared, the second sign changes, minus 2 times your terms, plus the last term squared. So remember those special rules for multiplying. It will be helpful. You can always use the full distributive property or FOIL to multiply them out, but using those shortcuts could save you some time. Okay, so let's rationalize the denominator. We have 6 over 2 minus the square root of 7. Our objective is to clear out that square root out of our denominator. Now, since we have a binomial down there, we want to multiply by the conjugate of our denominator, which simply means to change the sign of what's in the middle. So I'm going to multiply my denominator by 2 plus the square root of 7. So I will also multiply my numerator by 2 plus the square root of 7 to keep the fraction equivalent. Now I'm going to leave my 6 out there. I don't want to multiply it and then factor it back out. So I'm going to leave my 6 outside of the parentheses. And then I'm going to use my special rule for multiplying 2 minus the square root of 7 times 2 plus the square root of 7. The first term squared, so 2 squared minus the second term squared. Now I'm going to simplify my denominator. Two squared is 4. The square root and the square would cancel each other out. It just gives me 7, so 4 minus 7. 4 minus 7 is 3. Or negative 3. And now I'm going to simplify the negative 3 and the 6. Negative 3 will go in the 6, negative 2 times. And I'm going to leave my answer in its factored form. Now you could also multiply that negative 2 back into there to give you negative 4 plus or minus 2 times the square root of 7. And that answer is okay also. All right, negative 7 over the square root of x minus 3. So the conjugate of my denominator is going to be the square root of x plus 3, just the opposite sign of what's in the middle. So just like in the previous problem, I would have the negative 7 on the outside times the square root of 7 negative 7 times the square root of x plus 3 all over a squared, the first term squared, so the square root of x squared minus the second term squared, using our shortcut rule for multiplying those. So my numerator will stay like it is. My denominator, I'm going to simplify that. The square root of x squared is x. 3 squared is 9. There's no way I can simplify that any farther. So that's my answer. Okay, let's look at a couple more problems. The square root of 2 minus the square root of 3 over the square root of 2 plus the square root of 3. Again, I want to multiply by the conjugate since I have a binomial in my denominator. Conjugate, just change the sign in the middle. The square root of 2 minus the square root of 3. Whatever you multiply your denominator by, you have to multiply your numerator by the exact same thing. Now in my numerator, I have the same binomial. So we can use the rule of a minus b squared to multiply that out, which gives us the first term squared minus 2 times the terms plus the last term squared. That's the shortcut. Or you could use the FOIL or full distributive property to multiply that out. I'm going to use the shortcut. The first term squared, square root of 2 squared minus 2 times the terms. 2 times 3 under the radical, 6, plus the last term squared. Using my shortcut. In my denominator, use my shortcut rule for that for the sum and difference. The first term squared minus the second term squared. Now the 2 times the square root of 6, the 2 comes from the formula for our shortcut. The 6 comes from the first term and second term. Square root of 2 times the square root of 3 is the square root of 6. That's how I got that in the middle. Now let's simplify a little bit. The square root of 2 squared is simply 2. The square root of 3 squared is simply 3. Same thing in my denominator. Okay, let's combine the like terms. 2 plus 3 in my numerator is 5. 2 minus 3 in my denominator is negative 1. So I can divide each one of those by negative 1, which would simply change both of those sides. So I end up with negative 5 plus 2 times the square root of 6. All right, let's look at one more example. We have the square root of x over the square root of x minus the square root of y. So again, we have a binomial with radicals in our denominator, so we want to use the conjugate of our denominator, multiply by the conjugate, which in this case will be the square root of x plus the square root of y. And again, whatever you multiply your denominator by, you have to multiply your numerator by the exact same thing to keep the value of that fraction equivalent. Okay, now in our numerator, we don't want to leave that square root of x outside of our parentheses. So let's go ahead and multiply that in so we can simplify. So we have the square root of x times the square root of x, which is the square root of x squared. And then the square root of x times the square root of y, square root of xy. In our denominator, use the shortcut for the sum and difference. The first term squared minus the second term squared. Okay, so in our numerator, the square root of x squared, remember the square root and the exponent squared will just cancel each other out, so that will just give us x plus the square root of xy. In our denominator, the square root and the square cancels out, so that gives us x. Same thing with the y, so x minus y. And I cannot simplify those pieces. Now remember, you cannot simplify individual terms, so I can't simplify this x in my numerator with this x in my denominator. They are both within binomials, and the binomials are different. So therefore, that would be my final answer. Okay, I hope you found this video to be helpful. Thank you.